record this just so that this is available for other students that will like it. All right, so I'm going to focus here on the IXL assignment here for transformations. Let's start with that one. Oh, actually, no, we went over this yesterday. We don't need to go over that. Let's just go to Deltamath transformations. This assignment right here, week 4C. Okay, so I'm going to jump on these ones right here. So there's like 6 different rigid motions that you're looking at, and you're basically trying to come up with which transformation is it. All right, so like here, for instance, on this one, it says figure L is the result of a transformation on figure K. So just so that your guys aren't confused, I know that it says figure L first in the sentence, but you're not going from L to K. You're actually going from K to L. It's saying that L is the result of a transformation. So that's what happened after the transformation. So just go in alphabetical order when you're trying to think of like, okay, what shape am I starting with and which one am I going to next? So really it's going from figure K to L, okay? So what is a transformation? Now the best way to do these is first say to yourself, is the shape like been turned? Is it like been flipped upside down? Or is it still pointing the same way? Like, is it still oriented the same way? And does it look like it's just kind of like shifted over like this? Because as soon as you see that it's kind of like maybe turn its orientation a little bit, then that means it's either going to be a flip or rotation, not a translation, okay? So you can see here that this thing just kind of like shifted up to the left. So that you know that's going to be a translation. So pick one point and then figure out what is like kind of the path that point had to travel to get to the next spot. So if I'm looking at this point to the right here in the middle at this point, that's this point here on the new figure. So I'm going to basically trace going to the left 1, 2. So that means a translation to the left 2 units, and then up 1, 2, 3. So let's see which one matches that. So 2 left, 3 up. It's the first choice. All right, so that should be my correct answer. All right, so we're good there. All right, so again, and the nice thing too is like usually this will kind of show you what that looks like. So you can see here, it's shifting to the left, and then it goes up 3, okay? And each of those points does the same thing. All right, so let's go to the next one. Okay, so this is another one. Again, you could see that the shape is still like kind of the same orientation. It's just moved. And remember, follow alphabetically the lettering. So K to L, same thing. So I'm going to look at this point right here on the bottom left edge. And to get to this point over here, let me use some annotation. I'm going 1, 2, then 1, 2, 3. So down 2, left 3. Okay, clear that up. All right, so that means my answer, or let me get rid of that there, would be down 2 and left 3. Let's see if I got a, uh-oh, why is it doing that? Oh, I got to turn that off. Okay, there we go. So let's see which one has down 2. This one has down 2. It's just kind of work, you know, they went 3 left first in the sentence. So 3 left, down 2. Okay, so that's a basic translation. All right, so now let's go to the next section. Now, if you look at these 2 shapes, again, remember we're going, think alphabetical. If you don't remember your alphabet, sing it to yourself. A, B, C, D, Q, R, oh yeah, Q, R. Okay, so this one, the shape has changed. It's no longer like just moving straight, or actually in this case going down. It's actually kind of either rotated or flipped. And if you're looking at it, it's literally the same image. It's just been kind of flipped over. It's been flipped over this line, the x-axis. So really just look at one point. This point is now this point. And look how right in the middle of those 2 points is the x-axis. If I go to these 2 points, right in the middle is the x-axis. So that means that that's what it flipped over. And that's called a reflection. Okay, so I should say reflection over x. And there we go. So that section is going to be like And here you can see that kind of flip happening. See how it kind of flips down. All right, so that's a reflection over X. Okay, here's another example. Same thing. You can see it goes from S down to T. So another flip right over the X-axis, or a reflection over X. Okay, so let's go to the next section now. Now, again, we're going to go from K to L, but now we're not going from the bottom to the top. Now we're kind of going across. We're going from, looks like the left to the right. So now, kind of the same idea. It's a reflection, except now we're going left to right. So that means we're flipping over the Y-axis. Okay, so think about like jumping over a rope. If you guys ever did, what do you call that? Like the little thing, you know, back in elementary school when you, what is that called? Jump rope. I think it's jump rope, right? Just jump rope. And you're jumping over the rope, right? So it's like you're jumping over the Y-axis. All right, so that's how you know it's a reflection over a Y-axis and not the X. So don't. That's a part that I'm making the point of, is that you're going to see two choices, like over X or did I go over Y? Well, pick a point. If I go from here to here, which line did you cross? Did you cross this X line, X-axis, or did you cross the Y-axis? And that's why you'll know. Okay. All right, so let's go to the next section. Again, remember, these are all one answer sections. So every time you answer one, keep track of your record up there to the, actually I guess it would be this way that I'm pointing, up in the corner there, so that you know that you're on the right track. All right, so now take a look at this. So this is a little different. Let me go to the previous section. So this is the last one. Notice how you can see how it like flips right over. So, and we saw that kind of animation. Actually, let me see if I can show the example. So you see how that kind of like flips right over to the next spot. Now just imagine the next section and see if you can do the same thing. Okay, so let's go back to original problem, next section. Can I take figure B and do the same thing and flip it over and get the same thing? Well, no, that wouldn't be a flip. So the other thing is, it's kind of like shifted its orientation. So that also means it's not a translation. Okay, so that means our only thing left is a rotation. So it means it rotated. It kind of like went from what we would call this quadrant 2 over to quadrant 1. And if it moves over just one quadrant, like I told you guys yesterday, that means we're going 90 degrees. Okay, so we're just going 90 degrees here. Kind of, and if we're going this direction, that means it's clockwise. Let's think about how a clock turns. All right, so let me get, I want my color. All right, wait, go away. I don't want that. I want this thingy. All right, there we go. So I'm gonna look at this point, coming to this point, kind of doing this rotation. And if I'm moving one to one quadrant, that means it's 90 degrees. So let me clear all this stuff up so we can scroll down here. So that means a rotation, not counterclockwise, but clockwise around the origin. Okay. So really, I think for rotations, just think about like how many like quadrants is it moving to? Going from the left to the right, or is it going kind of to the right and then down to the next one? That'll kind of give you an idea of how many degrees you're turning. So you can see this one rotating. You guys see that? Rotating to the right, 90 degrees. Okay. All right, so let's go do another one like that. So here we're going to go again. Now remember P to Q. So that means we're going up to the right. So that means here, that means we're going to go here, moving one quadrant. Again, that's 90 degrees because we're only going one. But now, again, we're still going in the direction of a clock. So that means it would be a 90-degree clockwise direction. Okay, so that means we should see 90 degrees clockwise, not counterclockwise, we want clockwise. Okay? All right. So what's this one? G to H, so that's the same thing. Let's go to the next section. All right. All right, so now again, first Einstein, you might think, oh, that's a flip because it's going from like the top A down to the bottom. But notice how it's not really like oriented the same, right? If I flipped this point down to here, it's like, wait a minute, that point's not here anymore, it's over here. Or this point right here that's on the end of it, if I flip it down, it should be like right here, but it's actually way over here. So that means it kind of like rotated down like this. I guess if on the screen it would go like that. Okay, so that means we've got another rotation here going like this. And now we're going the other direction. So same thing like the last one, except now we're going counterclockwise. So that's really the only difference here on this one, is now we're going 90 degrees counterclockwise. Okay, so let's go to the next section. Okay, now we're not just moving one quadrant, we're moving over two quadrants. So we're going from F to G. So we're going 1, 2 quadrants in the rotation. So if we go 2, it's not 90, it's 90 plus 90, 180. Okay, and it's going back in this direction, so that means we're going to be going counterclockwise. So I should see down here 180 degrees, and it's the only rotation choice, 180 degrees clockwise. So that's kind of how you do that, okay? You have to just pay attention to how many quadrants are you moving, and you can see here how it moves. Actually, it looks like, yeah, they went, oh, so that's why they only gave you one choice, by the way, because technically I could have gone clockwise or counterclockwise. And actually, I think I just said out loud counterclockwise, and the answer was clockwise, by the way. Nobody called me out on it, whatever. But because 180, when you go 180, you technically could go counter or regular clockwise and still end up with the same image. I think that's why they only gave you one choice, okay? All right, next section. All right, now determine a series of transformations that would map this polygon, A, B, C, D, E, this red one, onto polygon A, B, C, D, E. Okay, so now let's use the same idea. Okay, can I just flip this down to here and get that same thing? Or should I rotate it? Okay, now if I rotate it, it should almost end up in the same kind of region in that next quadrant. Okay, so if I just rotate A down to here, it should end up like here, not way over here on the other side. You go over doing the composing. Is that a question, Mika? You would like to go over that one? Yes. Oh, yes. I am going over that one, if that's what you're asking. So yeah, this is in the list. This is that last one. Okay, composing. Okay, so I started to think, okay, so I want to rotate it down. Okay, but it looks like I also need to move it over. So let's try that. So maybe a rotation down. Let's try rotation. And I'm going down to the next quadrant, so it's only 90 degrees, and then followed by a translation. And so let's think about this. So if I rotate this A, let me get out my little marker thing here. If I rotate A, it will come down to here. Let me zoom in a little bit. Zoom in. All right, I had to zoom in before I start the drawing. Still trying to get used to these tools, even though it's only been a year doing this. All right, so here we go. So I got to rotate this guy down to here. Okay, because if I'm going to go, like I told you guys, I was telling you guys yesterday, let me measure this out. I look at where this point basically relates to the middle or my origin. And from the origin, it goes basically 1 to the left and up 2. So that I'm rotating down to here. So it's like I'm rotating this triangle down So that means I'm going to go here, down 1, left 2. So you can see how I'm rotating that down a little bit here. And basically, I'm focusing on one point, by the way, guys. Again, I'm just looking at one point. I'm trying to think, how can I get this down to here and then move it over here? Well, that means I got to move it down to this point and then shift it over 3. So some of you guys can visualize this. Some of you guys are going to need to write it out because I know that we all see things differently. Some of us like this kind of image type stuff and we can kind of see it in our brain. And I know for some of you, this is a challenge to like see this in your brain. So you kind of might have to draw this out on paper and see it yourself. Okay, so then I'm moving this down to here and then I'm going to shift this over to the right 3. Okay, so let's try that out. So that was rotate 90 degrees counterclockwise. I was coming down here, and now I'm going to translate 3 to the right. Try it out. There it goes. Okay. So let's watch that again. Okay, so in this case, so this is another solution. So there can be more than one solution here. Notice how what they did first is they translated. They actually moved it, shifted down first 3 units, and then rotated from there around the origin. So it's like I did the same thing, but I just started with the rotation before I did the. And by the way, after this, if you guys want to stick around and you guys want to do this together, like if you want to like work through these problems after we're done, please do that. Okay. All right, let's do like one more of those. And you have to get 2 of these correct. All right, so now again, we're going to go from the red one to the blue. And you always know which one you're going from because the new one will always have these little marks on the letters. And those are called prime. So here you would just say this is point A. Here on the new one, you would say this is point prime A, or A prime. You just add that on to it's fine, Andy. Okay, so we're gonna go from here to here, right? Now you notice again, it's not like oriented the same, all right? Now, some of you guys might think, okay, let's rotate it, all right? So let's just see what happens when we try to rotate that, okay? So here, I'm going to measure. I'm starting with this point. Actually, let me zoom in so you guys can see it a little better because I know you guys are watching on the screen. It might be easier for y'all if I zoomed in. Okay, that's probably a little better. All right, so I'm doing on time here. Okay, yeah, good. All right, so here's D. And to get to D, I'm going to the right one and up 4. And what I want to do is rotate it over. Okay, I'm going to rotate it over to the next region, which will be 90 degrees. So that means I'm going to rotate this triangle over to here. So that means this point will come to here. So now I'm going to go, oops, sorry. This triangle is the ugliest triangle ever. All right, let's do that a little better. Okay, that looks better. All right, so that means that I'm going to rotate this to here. This point will come down to here. That's why I just need to redo that. Okay, and that here will the triangle look like this, right? So that means this point will come to here. But then after that, to get it up here, I'm going to have to translate it. But notice it's not in the same spot because that's the point I need right there. And if I move it up, it's not the same point anymore. So that one's not going to work. So let's clear that. All right, so we need to do something else. Let me pause here. All right, so that means that basically now we're going to focus on D and we're going to go straight up. And that's 6 units. And then we need to jump from here to here and we're going to flip it over the y-axis. Okay, so let me clear this out and let's zoom out so that we can. So we're going to go translate up 6 units followed by reflection over the y-axis. Okay. Let's see how that works out. Flips over, bam. That's the thing I like about this, is that like we'll actually show you what happens. Okay. All right, and I'll stick around if you guys want to like have some help with that and work on that together. Okay, but I want to go over to the dilation scale factor because I want to finish with that. All right, but if you guys want to stick around and get some help with that one, I will be here until like 1 o'clock. All right, so first let's start on the IXL for dilations and scale factors. Now remember, the dilations means that we're changing the size. Rigid transformations, not changing the size. All right, so this one here, and don't forget to sign in when you guys start these. Okay, so these are pretty simple. Is it enlarged or is it reduction, right? We're going from the black to the colored one. So that's pretty simple. It's enlarged. It's getting bigger. Here we're going from the black to the colored. You always start with the black and then go to the colored one. So that's a reduction. Reduction for you guys there. Remember, reduction means that you're decreasing something. Enlargement means you're increasing something. All right, so we're going from black to color here, so that's another enlargement. All right, so this one's pretty simple, all right? And I think you got to get, what, 60 points? All right, let's go to 60 just in case. All right, so now it's asking for the scale factor. So that's a little different. All right, so here's how we do that. Pick one side of these shapes. All right, so I'm gonna pick this side, and don't pick like a diagonal side. Pick one that's either going straight up or straight across. All right, and measure it. So from here to here, that's 4 units. The same on this other shape. Make sure I'm putting here. On the other shape, we're going from here to here, and you would count that out. 1, 2, 3, 4, 1, 2, 3, 4. So we're going from 4 to 8. So if I'm going to write that down, I'm going from 4 to 8. Well, think about it. What would I have to do to go from 4 to 8? Well, I'd have to multiply 2. Okay, so the scale factor here is going to be, oops. Oh yeah, I got to turn this thing off. Be 2. Stop it. Go away. Keeps on trying to come back. Oh, maybe all I have to do is click that button. Okay. All right, so now we're going to go from a smaller shape to a bigger shape. And here, this side is 6. And then this side right here is, ooh, that's a lot. We're going to go from 9 down to -9. So that's 18. So we're going from 6 to 18. So what would you do to 6 to get to 18? Multiply a 3. Okay. So again, I'm going from one side of the square was 6. The next side of the square was 18. So from here to here, basically what you do, if there's like a formula for this, guys, you take your new shape and you divide it by the original shape. So what you do is you take the new shape, divide it by the old shape, and that's going to give you your scale factor. Okay? Take your old and divide it by the new. I'm sorry, new and divided by the old. All right, so again, here now we're going from big to small, right? Okay, so let's see, how many points do I got to get on this, just to make sure I don't go too far. Okay, so now here, again, I want to pick a side that's straight up and down so I don't have to like measure this and do all that extra stuff. Okay, so here, this one looks like it goes from here to here. It's going from 6 down to -3, so that's 9. And then from here to here, that's 3. Okay. All right, so now, old shape, new shape, that was 9, this is 3. Remember, from new to old, or divide new by old. So 3, the new shape, divided by the old shape, is 3 over 9. So some of you guys might go, oh, it's 3. No, you can't divide 9 into 3. So what you can do, what can you do with that fraction? Let me pause it again. All All right, so basically we're dividing both of these by 3, and the scale factor is 1 over 3, okay? So basically when you go from a big to a small, you're gonna get a scale factor less than 1. If you're going from a small to a big, then you're gonna get a bigger number that's bigger than 1. Okay, so in this case, we put 1, and here all you do is 1/3, okay? So that's how you do those. Again, take a side that is either horizontal straight across or straight up and down, okay? All right, so then going over here to Deltamath, it's the last one, actually, sorry. This is the last one we'll look at, not the quizzes. Okay, so 4D. All right, so composing transformations. All right, so now you're doing multiple things here. You're shifting this thing, and you are reducing it, okay? So here, first let's start with the shift, okay? We're gonna shift, actually, let's do the dilation first, okay? Okay, so the dilation that we're gonna do is we're gonna focus on the old shape and the new shape. So first let's figure out that scale factor. So remember, we take the new divided by the old. So the new one is 2. The old one is 6, all right? So this little shape looks like that. New shape looks like that. All right, this is 2, this is 6. New divided by old, which is 1 over 3. Okay, so that's our scale factor. And then we're going to follow that up by moving it up to here. Okay, so let's focus on A, and let's see what happens. So we're going to go over, we're going to go over 4, and then up 1, 2, 3, 4, 5. So translation. Okay, so that means we're going to go up. Okay. Oh, I see. Okay, so that means we're not only the dilation is not only squeezing this thing, it's not only making it smaller, it's pulling it basically towards the center. Okay, so what's happening here is we're pulling it towards the center here, okay, as we dilate. Okay, so right now what I want to do is look at how far away is this point from the origin. Okay, so from the origin, so let me kind of turn this off and clear it. Okay, because basically there's only, so what I'm saying is there's only one translation. Okay, we're not like going left and up. So when it shrinks, it's shrinking and pulling it towards the middle. Okay. All right, so here, the distance from the middle, we're gonna form a little triangle here. All right, so here on this side it's 6. Here on this side it's 3. All right, so we're gonna basically reduce this thing and start pulling it towards that side. So we're reducing everything by going from 6 to 2. So you're multiplying by 1, 3, or basically you're reducing everything by dividing it by 3. Okay, so we're gonna do the same thing with the triangle. So what I could do is I could take my scale factor and multiply it times that 6. Oh, that's right, I gotta turn this off. And go like that. Oh, there we go. So I take my 6 and I'm gonna multiply it times 1 over 3. I get 2. So that means that on that side of that triangle, this is going to reduce from 6 down to 2. This thing keeps jumping around. I apologize. Okay, so my triangle, if I put it over here to the side, will go from, it's going to be a little smaller triangle. It's basically going to change the distance from the center. It's going to come down to 2. And then I'll do the same thing with the 3. If I multiply it times 3, or basically divided by 3. Sorry, multiply it times 1 over 3. Okay, then I'll get 1. So I'm basically just reducing that down. Okay, so now I have 1 on this side. So that means I'm going to reduce it down, and now my new point, my A, will be here. Okay. Again, I'm going to probably end right after I do this example. If you want to stick around, I'll do more examples like this, okay? Because I wanted to keep today a little shorter. So basically, this point is not going to be reduced. It's going to be squeezed or pulled down towards this point. And now from here, I have to move up 3 units. Okay, so that's how far I know I have to go. Once I kind of pull it towards the center from the dilation, then I'll know where to go, or I'll know how far to translate. So I go up 3. So let's try it out. See how it starts to kind of pull it towards the center there and then go straight up? That's what's going on. Okay, so you guys can kind of see that in real motion. As you're dilating it, it's pulling it towards the middle. Okay, so the first thing, again, to repeat, that I had to do was measure one side. What was that scale factor? And that dilation is pulling it towards the center. And I had to kind of like draw a triangle to see how far that, to basically see how much I have to reduce that distance. And then I had to go up, okay? All right, so I'm gonna pause or actually stop the recording now.